Lesson 1-6 is on relations. In this video, you will learn to represent functions as well as interpret graphs of relations. This section has a lot of vocabulary, which includes coordinate system, coordinate plane, x and y axes, origin, ordered pair, x and y coordinates, relation, mapping, domain, range, independent variable, and dependent variable. Okay, so first we want to talk about how you can represent a relation. So when we have this, we have three different ways. The first one we're going to do is a table. So what we do is we start out with x values and y values. So remember, in a point, the first number is x and the second number is y. So I'm going to put those points in my table, 4 and 3. And then -2 goes with -1, and 2 and -4, and 0 and -4. This would be this relation represented in a table. Next one we're going to look at is a graph. That would be like as if we were plotting those points. So I can plot the point 4, 4, 3, and that would be like about here. -2, -1 would be here. 2, 4, 2, -4 would be about there. 2 and -4, and 0 and -4 would be there. So that's how you would represent this in a graph. And the last one is called a mapping. That's when we have our domain and our range. So domain, and in this case, it's x, and our range, which is y, and we put our numbers inside of it. So all of my x values, I have 4, -2, 2, and 0. For my y values, I have 3, -1, and -4. And then I draw arrows from the domain to the range. So 4 goes to 3. So I draw that like that. -2 goes to -1. 2 goes to -4. And 0 also goes to -4. Part B, it says determine the domain and range for the relation. So that's basically what we just did. The domain is always the x values. So what we have drawn here, this is our domain, 4, -2, 2, and 0. And our range is 3, 1, and -3, -1, and -4. So we can just say domain, and we put it inside the curly brackets, and we say 4, -2, 2, and 0. And then our range would be 3, -1, and -4. We don't have to list -4 twice. We only list each thing once in domain and range. Okay, so you guys say which of these is a mapping of that relation. Example 2. In warm climates, the average amount of electricity used rises as the daily average temperature increases and falls as the daily average temperature decreases. Identify the independent and dependent variables for this function. So basically we're saying that throughout the day the temperature goes up and down. So our two variables are the time during the day and the temperature. And we want to be able to say which one is independent and which one is dependent. So the dependent variable always depends on the independent variable. So usually the independent variable, that one is usually like the consistent thing. So like each variable, like each measurement we have is an equal spacing apart. And the dependent variable is usually more varying in the spacing. So if we're thinking about time with temperature, time, we're measuring throughout the hours of the day, they're equally spaced out. Time is going to be our independent variable. And temperature is going to be our dependent variable. So the temperature during the day depends on what time during the day it is. Generally in the middle of the day it's hotter. Earlier and later in the day it's a little bit colder. So the temperature is dependent on what time it is during the day. Okay, number 2 says the number of calories you burn increases as the number of minutes that you walk increases. Identify the independent and dependent variables for the function. So which one of these depends on what the other? So if we think about this, the number of minutes that you walk increases the number of the calories you burn, right? So the more you walk, the more you burn. So the calories burned depends on how much you walk. So that means that a number of minutes walking this is going to be our independent variable. And that means the minute or the calories burned that is going to be our dependent variable. Okay, so the number of calories you burn depends on how many minutes you walk. So that makes calories the dependent because it depends on something else. Okay, you guys try this one. Okay, example 3. It says, the graph represents the temperature in Mrs. Ling's classroom on a winter school day. Describe what is happening in the graph. So this is time. As time passes, this is what's happening to the temperature in the room. It looks like it increases steadily, and then it gets to about like a range, and then it drops, and it goes up, and it drops, and goes up, drops, and goes up. So we're trying to come up with our own explanation of how you can do this. So one explanation could be that she has the air conditioner on, or the heater. Let's think that this is the heater, and it was cold, and she turned on the heater in the morning, and it got warm until it got to a certain point, and then it shut off. And so it started to fall until it got to a lower point, and then it turned back on, and then it would shut off and turn on. So if you're familiar with a heater or an air conditioner, they usually have a temperature that once it reaches it shuts off until it gets to another lower temperature, and then it turns back on. If you did not know that, you might say, well, maybe she was opening and closing the windows throughout the day. And so it would get hot and then cold and then hot and cold. And that would be a decent explanation too. So there's not necessarily going to be one right answer, but the answer you give has to make sense based off of what is going on in this graph. So here it shows it increases, it goes up and down. Okay? So you guys think which would be doing a good explanation for this one. And that's the end of lesson 1.6.